Hello everyone, I'm Leslie Wöhler from the Computer Graphics Lab at TU Braunschweig, and I'm happy to present our work towards understanding perceptual differences between genuine and face swap videos. First, let's look at face swap videos. For these videos, the face of an actor is replaced with the face of another person while keeping the movements and facial expressions of the original actor. As can be seen from the example, the quality of state-of-the-art face swaps is high, and they can be unobtrusive or even undetectable for viewers. This offers great possibilities for creative scenarios, but also leads to problematic situations, where face swaps are used as a tool to create defamatory video material. Therefore, the detection of face swap videos is an important topic. Current methods to detect face swaps are based on image analysis systems and rely on the detection of specific artifacts. Different from these methods, humans are inherently very sensitive to faces and excel at facial recognition tasks. In our work, we aim to gain knowledge on the perception of face swap videos and investigate which features or artifacts are important for humans to recognize the forgeries. These insights can be used to improve detectors. We conducted 3 experiments to investigate the perception of face swap videos. These focus on eye tracking, the effect of video length on the detection accuracy, and the conveyed emotions in face swap videos. First, we investigate eye tracking, as it can be used to assess artifacts and could easily be integrated to face swap detection frameworks. In our experiment, participants freely watched face swaps and genuine videos with a duration of 60 seconds, where we recorded their eye movements. In this experiment, we investigate which facial areas attract the gaze of viewers. Our hypothesis was that especially artifacts like unnatural eye movements or overlapping facial contours would influence gaze. To better assess the impact of the artifacts, we use face swaps of high and low quality. Furthermore, we wondered whether participants would notice the face swaps without being informed about them beforehand. Therefore, we asked participants to freely report their impressions of video quality and artifacts. The results show a significant difference in gaze between genuine and face swap videos. In high-quality face swaps, fixations are more prominent on the nose and mouth than on the eyes. This indicates that eye tracking data could be used in pipelines to detect face swap videos. We also found that artifacts are not generally more salient if they are reported by participants. Especially artifacts on the facial contours bias the fixation behavior for low-quality face swaps, even though they were reported less often than artifacts on the eyes. Based on the 3 answers, we find that participants notice artifacts like blur or contour artifacts, but usually attribute them to bad video quality and compression. In the first experiment, we used video durations of 60 seconds to give participants enough time to explore the video. In the second experiment, we wanted to assess whether the video length has an impact on the detection accuracy of participants. Here, participants were informed about the concept of face swapping before the experiment, and for each video had to decide whether it was a face swap or a genuine person. We found no significant differences between the conditions. This may indicate that participants are able to quickly decide whether a video is genuine or not. Additionally, we found that participants were only able to detect around 25% of face swaps. This shows that state-of-the-art face swap videos are convincing, even when participants know about the method beforehand. As our first 2 experiments generally showed that face swap videos are convincing, we decided to look into whether they are also able to preserve the same emotions and expressions as the original videos. For this, we used short clips showing isolated emotions and expressions. Using these stimuli, we investigate whether participants can correctly label the emotions in the videos. Additionally, the participants rank the sincerity and intensity of the displayed emotions on a Likert scale. Our results show that participants rate the emotions and face swaps similar to real videos. We did, however, find significant differences in the recognition of disgust. Further, disgust, cluelessness, disagree, and thinking were rated differently for intensity and sincerity. This indicates that face swaps are overall able to convey the intended emotions and expressions, making them even more powerful. In our work, we found that participants are able to recognize artifacts in state-of-the-art face swaps, but only seldomly attribute them to manipulations. Furthermore, we investigated eye tracking patterns and found significant differences in fixation behavior, which could be used to detect face swaps. Interestingly, the length of video clips did not influence participants' assessment accuracy, indicating that even long videos can successfully mislead viewers. Finally, conveyed emotions and expression in face swaps are not yet completely indistinguishable from reality. However, the generated results are already very close to be visually non-detectable. Seeing how face swaps are already highly convincing, we believe it is also important to discuss ethical and legal regulations for these manipulated videos. This concludes our video. Thank you for your attention.